welcome back to the channel. If you have ever wondered how apps like Amazon, Netflix, or even Zomato manages millions of their records so smoothly, the magic word is SQL. Today I'll be breaking down few powerful concepts in SQL that everyone must know. Let's dive in. These are the concepts which we'll be looking in today. Data types and normalization, operators, and what's the difference between primary and secondary key. Before diving into data type, I want you to understand every piece of data in database has a type. Just like you wouldn't pour your soap in a paper bag, you wouldn't store your bananas in an egg tray, or you don't put a number in a text field. Similarly, every data you enter in a database has a type. Let's look into the most common SQL data types and when to use them. These are the SQL data types. Looks a lot, right? Do not worry. Allow me to make it easy for you. We use these data types to tell database what kind of data you are storing in each column. For example, in the numerical data type, there are data types such as integers, decimal, and float. In order to make it clear, we use data type integer when you're storing whole numbers. For example, if you're trying to store mobile numbers, which doesn't have any point value, like there won't be any mobile number such as 123.4. It will be a complete number. So if you're storing such kind of a data, it doesn't have any fractional or any decimal values in that, we will use a data type such as integer. And we use decimal, like this is most common in online platforms. When you're ordering any particular thing, there might be a certain fractional value such as your discharge value, your delivery charges are something 27.50, or there is a discount of 77.50 and such sort. So in that data types, we used data types such as decimal for those. For float, if there is an not exact decimal value, for example, the value of pi, or if there is a segregation such as how if there is an extra decimal value, that 3.3333. So instead of having a large decimal value, we will approximate it to the closest one, like we'll take it as 3.4. So then is that at that time we'll use a data type such as float in that regard. A best example is like product prices in the e-commerce database use decimal values for accuracy. The next one is text type, very important. Uh, we will be using data types such as character, variable character, and text. We will use a data type character when there is a fixed length text, and we will use a variable character when the text type is not can be varying. Allow me to also give a brief example about it. For example, Mm, variable character limit. If you take, we will be using the data type in this format. We are taking the data type as character with a limit of 3 letters. And similarly, we are taking a variable character with a character limit of 3. If in this case, you're storing the data, we are using 3 to store the data for yes, yes. Instead of yes, if someone has entered the value only as y, so if you are using a data type as character, then database will store it as y space space as because as you have given a fixed length, even if you enter or not don't enter, the database will capture it as a fixed length character. Whereas in a variable character, even if you have entered, despite taking the character limit as 3, if you have only entered a single letter, it will calculate saying that as the only one letter has been taken, it will just capture it as y instead of space and space. That's the major difference between character and variable character limit. The major difference stands for the first thing as we have discussed about the length. The length is fixed in the character, whereas in the variable character it varies. The second major important point is about the space efficiency. Character data type is less efficient, whereas variable character is more efficient. It can judge and it can capture the data in a very nice and very compact format, not taking much of the space in the our storage servers and all. With relate to the speed, obviously character will be fast and variable character will be slightly slower because character will take the direct data without even calculating or understanding whether to capture the space or not to capture the space. That's the reason why variable character limit is slightly slower when compared to the character data type. The last major difference is that for any particular flags or particular codes, we use a character limit. But for names, email IDs, we'll use variable character. And text is if there is a large block of text which are using. To give an example, if you go to the any online platform, there are two things. There's a star rating and there's also a review. So in star rating, we'll use variable character limit because there is a range 1 to 5. That's the only range which you can enter. You can't enter any desired value in star ratings. Either you can pick from 1, 2, 3, 4, and 5. So we are also giving a particular length, but also we are not finiting it. We are varying. There's a scope of being variance. You can either get a data in the form of 1 to 5 within the range. So there's a good example of using variable character limit for star rating to store the data. And similarly, you might have seen the reviews. There is no limit for that. You can write n number of lines for any particular product if you want to review. For that data types, we'll use data types such as text. So the best example is if you're using star rating, we use data type as variable character. And if you're storing the data such as review, we'll use the data type such as text for that. The next data type which we'll be looking is date, time, and type, as it is very self-evident. If you're capturing the data values as date, we will be using data type date. If you're capturing time, we will use time. If you're capturing both date and time, we will be capturing date time data type, and this goes. And one crucial one is the Boolean type. Uh, Boolean type. We use Boolean data types when we want to store only two possible values, like true or false, or if there is a binary format of 1 or 0, we use the data type such as Boolean one. So we are introducing a new segment called as quiz. This will help you to revise also assess your understanding about the concepts. Here is the question. What all data types will you use if you're creating a table to track your monthly expenses, which has money to a roundup value, type of expense, and date of expense? I request you to kindly pause this video, get your answers, and then resume the video to match them with mine. If you're ready with the answers, allow me to present mine. So as type of expense is shopping, we will be using data type as variable character. We will be giving a limit of 50 characters, but we can be varied if we are not, someone is not using, because if one type of expense is shopping, another type of expense is food, the number of characters of food and shopping are different. If you're using character, so if you're giving a limit of 10 and food as it is taking only 4 letters, then the rest of 6 letters will be empty or will be captured in the form of space. So in order to avoid this extra space in our storages, we are using variable characters here. And date of expense as it's a date, we will be capturing it as date. And as it is money in a non-decimal format, we'll be capturing as integer. Hope these data types match with yours. The next thing we'll be looking up is about data normalization. Data normalization is nothing but cleaning up the mess which you have created. It's like organizing a wardrobe. Your wardrobe will have clothes in it. Organizing it in neat, tidy, and efficient manner is what data normalization is. If you look here, this is an actual data, which is very large cluster, which is not in a particular organized form. If you're particularly grading it, if you're particularly segregating it based upon the requirements, that's for normalizing it. If you're also grading it to the access level, that's what standardization stands for. This is a very good example in related to the SQL database. If you look here, A to H is a data form, which is an unnormalized form. All the data has been clustered over here. If you're removing any repeated and redundant values, we are segregating them into a smaller tables. That's what normalization is. This 1F, 2F, and 3F stands for first normal form, second normal form, and third level of normal form, which goes for multi-layer purification. Multi-layer segregation of the data is 1F, 2F, and 3F, which we will look on going forward. Let's look into the real-time example. If you look here, the first table is an original unnormalized table, which has all the values from order, ID to customer, and all the details over here. The problem with the first table is that there is a multiple repeated data. You can see there is a name repeated, address that is getting repeated, and it's hard to manage. If you want to make any particular changes, you want to have to make changes in all the database. But the moment we get normalized it, we segregate the data into multiple tables. You can see that the data has been clearly segregated into multiple tables. But the data of customers has been managed in customer table. If there is a data related to the products, it has been clearly managed in products table. And the data related to the orders has been clearly managed in order table. If you want, what's the benefit of normalization? There is no duplicacy. If you can check, there is no duplicacy of data. And if you want to update any particular information, it's very easy to update. Even for storing of this particular small data will be very easy and very easy to change or manipulate when and if and when required. And it enforces a consistency with the particular foreign keys or secondary keys that we'll look into going forward. Here again, we are with the quiz. This is the question. What problem do you think this table suffer from? And what are tables we need to make in order to normalize the state? Kindly pause this video, get your answers, and then resume the video to match them with mine. Okay, if you're ready with your answer, allow me to present. This unnormalized data has a large amount of redundancy. Both math and Mr. Sharma have been repeated for both students. So the initial unnormalized table was creating redundant or duplicate data multiple times. So we have normalized it. We have segregated into multiple tables such as students, courses, and enrollment. So remember, great databases starts with choosing the right data type, keeping data clean and structured through normalization format. The next very important topic which you're looking are the operators. Mm, if you just think that SQL is just about storing data, it is partially true, but not completely. SQL has operators, the secret sauce that gives your queries power, flexibility, and logic. In this video, we're breaking down the most important SQL operators with some real examples so you can filter, match, and manipulate data like a pro. Let's start. By definition, SQL operators are symbols or keywords that help you perform comparisons, filter data, combine conditions, or do calculations. Think of them as the tools in your SQL database. We'll cover four major operator types, which are comparison operators, logical operators, arithmetic, and special operators. One good thing is that we'll be also writing some basic, very pretty small queries while learning about operators. This is the first step of our jumping and starting our query journey. So the first operator is comparison operators. As the word itself indicates, we are comparing two formats. And to how do we compare? We're comparing value with these operator forms such as equal to, non-equal to, whether it's greater or lesser than value. So this is the query which has been asked. Get all products under 500. Don't worry, it's very simple to write. Allow me. I'll read this query in a statement form so that you're able to understand. What has it been asked? We need to get all products under 500 rupees. So we are writing the query. What is an outcome we are getting? If there is n number of products, we need to get a final list of products which are under 500 rupees. If there are 10 products which are starting from 100, which are also ranging to 500, which are also 700 and 800 and 1000, we want an output which are under 500. So we will be selecting from asterisk strands here. Asterisk has two things. Asterisk also goes for all. Asterisk also goes for multiplication. So if we are selecting as asterisk has been used, we will be selecting all the data. Where are we selecting from? We are selecting from products table where price is lesser than 500. It's as simple as that. If someone asks you to get any particular things which are in this particular range, that's how you do it. You go, you pick them from particular place, and you select and put a criteria saying that this need to be reduced from this need to be lesser from this. And the next operator which we are looking for is a logical operator. As the word itself indicates, we combine multiple conditions using and, or not. You will be able to understand it with a very beautiful example given here. Find all, what's the query which has been asked? We need to find all the electronic items under 500 with a rating above 4 stars. Try to understand how many conditions which have been asked here. Guess. Yeah. So there has been three conditions which have been asked. The first, we need to find for electronics, and we need to find for items which are under 500 and whose rating are above 4 stars. So again, the same thing. We're selecting all the data which is asked from products table where for the first condition, category need to be equal. We are using again equal symbol which need to be equal. Category need to be electronics, and because everything need to be satisfied. It's not like any one category need to be satisfied. It need to be electronic. It need to be under 500 rupees, and it need to be above 4 stars. It's not like or. It can be electronic, or it can be under 500, or it can be 4 stars. It need to be like if you're planning to buy any particular for 500, what can we get? If a small headset if you're trying to buy, first it need to be electronic, and it need to be under 500, and it need to be above 4 star. That's what you look. So that's the reason and we are using. Where categories first is electronics, and the price is less than 500, and the rating is greater than 4 star. That's how you write a query. Congratulations, you're able to understand the query, and you're able to write a query in a very simple format. The next operators we are talking about is an arithmetic operators. We might be already aware of arithmetic operators. Arithmetic operators which perform basic mathematical operations such as addition, subtraction, multiplication, division, and modulus, which is a remainder of what. Even if you look, there's a query given here. We need to get total cost per order. How much is the total cost per order value? Like if you go to the shop and if you are buying two chocolates, what is the total cost per order which the shopkeeper is able to get from you? So what we are doing, we are selecting what is the product name. Why we are, as chocolate is one of the product name, we need to know. The shopkeeper or any database manager need to know what is the product name on which the particular sale has been done. So we'll be getting select chocolate, and how will we get total cost? For example, one chocolate costs you 100 rupees. If you're buying two chocolates, how will you get the total cost? You'll multiply your quantity and to the price of unit. Like for example, one chocolate is 100 rupees. 100 into 2 will give you total cost. In the same way, if you're buying five chocolates, quantity is 5 into price into which is 100, it will give you a total cost. That's how you'll write a query to get a total cost per order. Next are the special operators. Special operators are used for advanced level filtering. The filters are like, in, between, is, null, or not. It's very simple to understand. Like is like you're giving, like, again, let's understand it with a simple query. We're selecting all the data from the customer tables where name value is like it's starting with A. So you're not giving an exact mentioning, but you're saying that it is something close to this value. If it is something nearer to this value, that's when we use like. In is an operator when we use if there are multiple matches. Like for example, we're selecting all the data from the orders table where what is the status? What is the status of your order? Because we're selecting it from the orders table. Either it need to be in two conditions. Either it is shipped or it is delivered. So give me all the data of orders, all the data. See all from the orders table where status is either in shipped condition or either in delivered. If it is cancelled or if it is still pending, don't give me those orders. Just give me in these conditions. Like if it either it need to be shipped or it need to be delivered. This is when we use SQL operators. Between itself, understand if there is a range between. We are selecting all the orders from products table where we are getting a price between the range of 100 to 500. So anything it can be 100, 150, 350, 450, 250. If you're getting those output using this query, we'll use for any particular range search, we'll be using this thing. And the last thing is null or not null. Null and not null is very evident. Is null is if there is nothing. If it's not null, it indicates that there is something. Then that is when we use is null or not null operator. Again, let's go with a quiz. So this is a query. Write a query to extract student ID who is female and is about 20 years. Kindly know the name of the table is student data. Here is the hint. Select student ID from student data where gender is female and age is greater than. Kindly pause for a moment, write a query, and kindly once done, compare it with mine. Yeah, if you're done, let's look into that. So as we have talked, we are selecting student ID. We just want the output as student ID from what table we are opting from, student data we are opting from, what are the conditions we are using, where gender is equal to female and age is 20. It's not saying or, it is saying clearly, it is saying and, who is female and is about 20 years. So this is the query. Congratulations, you're able to write your first query. So SQL operators lets you take control on your data, filter it, search it, manipulate it. Whether you're building an e-commerce platform or any particular school database or for any restaurant databases, operators make your queries powerful and precise. Next step, we are diving into what is primary key, foreign key, and secondary keys, backbone of relationship database. Let's look into that. In short, primary key stands for uniqueness and foreign key stands for relationship. Let's make this easy using this diagram. We have two tables represented by these two circles. The blue circle on the left has serial number, contact number, location, and age. And pink circle on the right has name, contact number, salary, and email ID. Serial number in the left table is the primary key. It is uniquely identifies every row in the table. Think it as like your employee ID or Aadhaar number, which is very unique to every individual and which cannot be duplicated. Right? Every individual has a unique Aadhaar number to their own. So it indicates that primary key in any particular table need to be very unique and it should not have any null values in that. Meanwhile, if you look into both the tables, contact number in the right table is a foreign key. It is referring back to the primary. It is referring back to the primary table's contact number to establish a relationship. In order to establish, if you are able to extract data from these two tables, we need to have at least one column which is common between these two. As contact number is a common data type, or sorry, as contact number is a common column between these two tables, using which we can create a connection between these two tables. That is what a foreign key stands for. Again, I repeat, primary key is a unique identifier in its own table, whereas foreign key is a reference to another table's primary key. Like, think of this like a university database. The blue circle is the student information table, and the pink one is the fee payment table. The student ID is primary key, which is unique, cannot have any duplicates, should not have any empty or null values. And the contact number in the payments table is used to link the payment records to the current student. That's the foreign key. So while primary key keeps rows unique, foreign key keeps tables connected. Without them, your database will be isolated islands. With them, it will be a beautiful linked web of data. These are some differences between a primary key and secondary key. Please pause for a minute and check through that. As this is the same thing which you already discussed. Primary key is a unique value, cannot have null values. Only one primary key per table has it. The main way to identify record, as we already discussed. And that's about today. Thank you for watching. Like this video, subscribe, and comment if you have any doubts. Until next time, happy querying.